Welcome back to the Deep Dive. Today we're jumping back into the OEIS, the Online Encyclopedia of Integer Sequences, a fantastic resource for number theory students, as you know.
Absolutely, a real playground.
And our focus today is sequence A00291. It's often called bipartite partitions. The definition given is, well, pretty specific. The number of bipartite partitions of n white objects and 2 black ones.
Right, and on the surface that sounds maybe a bit narrow, like just a combinatorics exercise. But what's really fascinating and why we're looking at it is how this sequence unexpectedly bridges different mathematical ideas.
Okay, so it's more than just counting colored balls, so to speak.
Exactly. It holds multiple interpretations, which is often where the really interesting math happens.
Let's unpack that then.
Yeah.
What are these other ways to think about A00291?
Well, one of the, I think, most striking alternative views is that it also counts the number of ways to factor p to the n times q squared. And here, p and q have to be distinct prime numbers.
Wow, okay. So partitioning objects on one hand and prime factorization on the other. That's quite a leap.
It really is. And there's even another perspective Joe Grant mentions. It relates to multiset partitions, specifically partitioning the multiset R2, where you have in copies of one thing and 2 copies of another.
Brought a set, right, where repeats matter. Okay.
Yeah, so it just shows this sequence has, multiple facets.
This connection to prime factorization is particularly intriguing. Could you maybe walk us through an example, make it a bit more concrete?
Definitely. Let's take A2. The sequence goes 1, 3, 9, so A2 is 9.
Okay, the third term is 9.
Right. Now let's use that factorization definition. We need p to the n times q squared, so here n is 2. Let's pick, say, p2 and q3, simple primes. So we're looking at p squared times q squared, which is 2 squared times 3 squared.
4 times 9, 36.
Exactly, 36. Now, the sequence says there should be 9 ways to factor 36, and not just into primes, but all possible factorizations using integers greater than 1.
Ah, okay, so not just 2 by 2 by 3 by 3.
No. Think like 36 itself, that's 1. Then 18, 2, 12, 3, 9, 4. 9, 2, 2, or 9, 2, 2, 6, 6. Let's see, 6, 3, 2, 4, 3, 3, or 4 through 2. And finally, 22, 32.
Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9.
9 ways. See, the number of factorizations matches the sequence term. It perfectly mirrors the bipartite partition idea, just in a different context.
That's really elegant. It clicks now. So this isn't just some, mathematical coincidence then. It points to something deeper.
Precisely. It's not an isolated curiosity. Within the OEIS, you find formulas connecting A00291 to other sequences. That's always a sign of significant underlying structure.
Like what kind of connections?
Well, for instance, AN is actually the sum of 2 other OEIS sequences, A000000070, and isn't that related to ordered factorizations or composition?
That's the one. And A00097 involves sums of integers. So you see how different combinatorial ideas are linking up through A00291.
Yeah.
It's like a junction point.
Fascinating. And I saw mention of an asymptotic formula, too. For large, yes, there is. It gives an approximation for an as n gets very large, something involving exponentials and pi. It looks like roughly chi-squared 2 and 3 divided by some constants and powers of n.
Quite complex.
It is, but what it tells us is that even though this sequence arises from simple counting, its growth is predictable. It follows deep patterns related to partition theory. It's not chaotic.
And they're looking at the contributors.
Yeah.
Wow. Sloan, Chima, Gupta, Donald Knuth even. These are major figures.
Absolutely. Their involvement really underscores that this sequence, while maybe specific, has been considered important and interesting within the field for quite some time. It's well established.
So today we've gone from a simple definition about partitioning white and black objects to prime factorizations, multiset partitions, and connections to other fundamental sequences. Quite a journey for A00291.
It really shows the richness hidden in these sequences. And, it perhaps raises a question for you listening. How can such a simple starting point partitioning just a few items lead to these quite deep connections across number theory? Think about how factorization and partition concepts seem to echo each other. Maybe it invites you to explore those related sequences we mentioned, A00000000007, or even look up the original papers cited in the OEIS entry.
Definitely food for thought. We certainly encourage you to keep exploring the OEIS. You never know what connections you'll uncover. Thanks for joining us on The Deep Dive.